Hi everyone, here's a recording for you about the timers that we've got available for programming ladder logic in our SoMachine PLC programming. So I've got a little picture here with the three types, the T-on, T-off and TP, and you can see all of them are connected to the same input. So we're just going to do a little bit of a run through to see when we trigger that input, what happens to the different outputs. So that's our goals on the left hand side. Goal number 1 and goal number 2 there that we'll just have a quick look at for today. So first off, with these three types of timers, just make a bit more space here. So we've got, if we use the timing diagram method to explain what's going on with these ones, we've got A as our input, and then Z, Y, and X as our three outputs. So if we look at this input A, if we do just a very short pulse, say that's 1 second long, that pulse, and we'll see what happens to our three different timers. So the T-on timer, maybe I need to draw in my little vertical lines as well. We'll use a grey colour for that one. There's our rising edge part. There's our falling edge, so we can line up the other ones with that. So the output Z, using the T-on timer, that one starts its delay, so it's going to be off in the beginning, and it detects when A turns on, so that condition's okay, and it starts waiting from that point forward. And it wants to wait for 3 seconds before it turns on, but in this case, we've only got 1 second from that input. So yeah, Z can't do anything from that little short pulse. If we go to our next one, the off type of timer. So this one, at our beginning point, it comes to here and it detects that A has turned on, and it says, okay, there's no delay for the turning on part, so let's turn on immediately. And it stays on there for sure. The delay part for this one comes in from that falling edge of the input. So that's going to be your 3 seconds across here, 3 seconds, which say takes us to around here somewhere. So it's a sort of signal that we'll get coming out of that Y output. And our third type of timer, the TP. So that one starts off, comes to this point. It also detects this rising edge, and it turns on when it sees that rising edge. It's going to stay on for a little bit of time. And the thing with this one is, as soon as it starts doing its pulse, that's the point when it actually starts doing its 3 seconds of timing. So that one will come across to around here and finish. So yeah, my drawings worked out okay, so there's a little bit of a gap. So yeah, that short gap in between there just represents the different point that those two timers started their 3 seconds counting from. So if we do another little experiment with this one now and say it's going to turn on for much longer, so if that is about 5 seconds worth of time, and put in my grey line again for the vertical thing, there's a 3 second point somewhere around here. And there's the starting point, and there's our ending point. Okay, so we'll just check with this one how our three different timers are going to behave. So the Z for our on delay timer comes to this beginning point. That's where it starts doing its 3 seconds delay. So it stays off until it gets to the end of that 3 seconds. And then it says, okay, I can turn on at this point. I'm going to stay on only as long as that input is active. And then I'm going to turn off. If we look at our second one, the T-off type of timer, so we're going to get a similar sort of thing like we had before. It's going to turn on immediately, stays on as long as the input is active, and that's when it starts doing its 3 seconds from that point. So 3 seconds is going to take it out to here somewhere. And put my little dot, so saying that's where it starts its timing of its 3 second delay. And looking at our last one, the TP type of timer. So that one also detects when the input turns on. And the special thing about this one is that it just looks after its own timing. So it comes to the end of that 3 seconds and it turns itself off. So even while the input's still active, this one with the TP can make itself turn off. So it's always on for the same amount of time, no matter what happens with your input. So that's a quick summary of the behavior of those ones. And you can test those ones out for yourself and hopefully you'll get a similar sort of behavior. So the second thing that we need to be able to do is to use these timers to actually design some ladder logic. So I've put in some little examples here, which are looking at different conditions about how we're actually detecting these timing problems. Just put a bit more space in here. So with all of these ones, we've got what the time delay actually is, how long we need to wait, but we need to get some clues about which type of timer we should be using. So we've seen just before about whether it's the rising edge or the falling edge, or what sort of behavior is linking the timer and the output and the input. So in this one, if we look through the description, one of the keywords in here is exactly 5 seconds. So you won't always get a problem that says the word exactly, but it might say something similar. So looking at our diagrams we had just before, there we go, shrink it down a bit. So there's only one of these timers that always operates for the same period of time, for exactly the same time. And that's the one hooked up to our Z coil down there. That's the TP. So there we need to use a TP and the sensor part will be our input. And we've just got some output. So any sort of wordy problem, it's good to try and identify what these key words are in here that tell us about how we need to design the circuit. If you can't identify those things, then you're just guessing and there's a lot of different possibilities. So chances are you'll guess the wrong one. So just like any sort of engineering design, you need to look carefully at what the information is and then link up that information to the tools that you've got available to you to actually solve that problem. So if we just drew this one, we'd have an input, we'd have our TP with a 5 second value, and it gives a command to the output. If you want to with the TP type, you can also, looking at your input here, we can make that P type, or depending on the question, maybe you want to use an N type. So that's just make sure that you get that really short pulse of logic. And a really, really short pulse like that is enough to get is enough to get your TP timer to start running. Okay, so let's look at the next one. Grab one different color. So we've got a time delay value of 3 seconds in that question. It's always a good point to start. And let's look at what other clues we have. We have both outputs start at the same time. Okay, so at the moment, maybe it doesn't help too much. Let's see what's the trigger thing. So the output 2 is active. So that's, even though we've got two things called output in this problem, that's the one that we are controlling. That we're sending that output command into. So we're going to give it a 3 second activation to there. And we've got this clue here after output 1. So that means that output 1 is our input condition that gives the command to the timer. So we have our output number 1 goes to some type of timer. How we're going to decide what type of timer? So we've got these keywords in here. We've got after and deactivates. So deactivates, if we draw a little picture, it'd be like that, the falling edge. And if we look at the diagrams we had before, which timer is working from the falling edge? Here it is. That's our time delay there, starting from the falling edge of the input. So that one is output Y, which was the T off type of timer. So just put a note in here. If we're going after the output deactivates, that's the T off. So put that into our design as well. We've got a time delay value we have to use of 3 seconds. And that gives the command to output 2. The other thing that we had to check in this problem was it said both outputs start at the same time. So if we just check the behavior from the diagram we did before, so looking at our T off type of timer was the one in the middle here. So looking at these points, we've got when the input activates, yes, the output activates at the same time. That's good. And again, the same thing here. The input activates and the output activates at the same time. So yes, the T off timer is going to take care of that part for us. It's going to activate or allow both of those to activate at the same time, but make sure that the output 2 keeps running for a longer period of time. Okay, the third example. So we've got a time delay value, 2.5 seconds, and we've got some descriptions in here. So one key part is once the memory bit, the output activates once the memory bit. So that's the condition or the input that we're looking for. And it just says the output. So it's just a simple name. It could be a lamp or it could be a motor. It could be another memory bit. We don't know. But we need to also figure out from these words about which type of timer. So one key thing we've got in here is that the output stays on. And we also have this word once. So in this case, it's not meaning one time, it's meaning after. So we're activating the output after the memory bit has been on for 2.5 seconds. So if we've got that rising edge there, that's when we start our 2.5 seconds, which might take us to somewhere like here. Sorry, it's a little bit messy, but that's supposed to be the 2.5 seconds delay. So let's look at the diagrams we've done just before and see which one is going to match that sort of behavior. So here we go. In the line for the output Z, we've got this delay where the input activates first, then our output does nothing initially. It waits until that time period is finished. And then at the end of that time period, then it turns on. And the two things will turn off at the same time. So I think that was also one of the requirements in this short problem. Yeah, it stays on until it deactivates. So meaning that when that one turns off, the falling edge there, then we have to get a falling edge on our output at the same time. So yes, all of those clues, they tell us that the T on is the right type of timer to use for this one. So we would draw that as our input being that memory bit, our T on, and the 2.5 seconds in here, remember that our SoMachine timers, they can't do any decimal places. So we have to use the combination of the preset and the time base. So we could do time base of maybe 100 milliseconds and a preset of 25. So when you multiply the two of them together, you get the 2.5 seconds that's required. And we better just put our little coil at the end here. And I think that one was just called the output. So there we go. We've got 3 different problems showing how we can find those keywords in the problem and use those keywords to help us to choose the right type of timer. So I encourage you to go back and replay some parts of the video that you need to see a bit more of. Maybe you want to pause it and have a go at doing something for yourself as well. And the more that you practice these sort of things, practicing the behavior of the timers and practicing finding the keywords in these problems, then it gets easier and easier to solve these type of things. This little diagram I've got up in the top right for the timing diagrams for the different type of timers. When you're just practicing to begin with, I'd recommend having this sort of thing on paper in front of you or in a document. So maybe you want to do a bit of a screenshot to show something like this, although I've made it all messy now, sorry. But if you have your own version of this, you can really quickly compare the behavior of each timer against what you need to have from the requirements in your question. And after you've done more practice, then you can hold that sort of thing in your mind, and you'll be able to solve it without needing to look up the paper. But to begin with, I'd recommend definitely having like a simple set of programs like that with the 3 types of timers, and having your timing diagrams to show the behavior of these things. And that will definitely help you a lot when you're trying to solve these type of problems. So good luck with this, and we'll see you in the next class.